Okay, in this SpongeBob themed video, you guys are going to be taking notes on 2-3, 2-2, proving theorems. And before I get into this section here, I'd like you to set up your notes. Now, normally you take notes in your notes section, but today you're not taking a lot of notes, but our notes take up some space. So where we normally take notes, go ahead and cut that in half, and you're going to set that up as section A and section B. If you're watching this video, it's because you're in section B. On the back of your notes page, I'd like you to also cut that in half, and that'll be sections C and D. Okay? You're going to leave this part blank. And again, you're in section B. Okay, so I want you to recall that a theorem is a statement that has been proven using postulates, definitions, and other theorems. In fact, in the last jigsaw we did, I gave you the definition for a theorem. Now everybody's going to be getting the same introduction, so you don't have to take notes on it, but if you want to, you can. And I want to give you a quick kind of informational tour of what a proof is. So the first thing I want to show you is that there are a couple different types of two-column proofs. And it all starts with the most important part, which is a thought process. So suppose you're given a problem. Prove that if two diagonals in a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Now, I don't want you to fret about this. Just imagine that there's a given information and they want us to prove something. The first thing you would do is think about it. You'd look at the picture, you'd think about what it means, what's given, what theorems and definitions you have. Now, one option for proving a proof is writing it in a paragraph. So here, the author wrote all of his or her thought processes in an organized fashion, a logical fashion, to prove that the quadrilateral is a parallelogram. Now, the most common proof that we're going to be utilizing a lot is this one. It's called the two-column proof. Now, the two-column proof has a section over here. Here they wrote argument. We're going to call it statements. And on the right-hand side is the reasons, the reasoning why. Over here is where you're doing your math. You're showing your logical steps from A to B, from 1 to 10. It always begins with what's given and ends with what you wanted to prove. And on the right-hand side, it's the reason. It's the justification behind what you said. And that's what you're going to be seeing today, is a lot of two-column proofs, and you're going to be helping me fill in the reason why and the argument. So the first section of your notes is Theorem 2-1. Remember, I don't care that you remember that it's 2-1. I just want you to know that's the name for your textbook. But this one's cleverly called the midpoint theorem because here's how it goes. If M, and that's point M, if M is the midpoint of AB, then AM is half of AB and MB is half of AB. So they're just saying that if this is the midpoint, then AM is half of this distance and MB is half of this distance. That's it. Okay, so I'm going to prove to you the midpoint theorem using some given information. I'm going to prove what they say, that AM is half of AB and MB is half of AB, given this diagram. And I'm going to do that using a two-column proof, where I write my statements on the left and my reasons on the right. So you should notice there's blank spaces here that we're going to be filling in, and we're going to be doing our justifications on the right. So we're going to prove the midpoint theorem without a doubt. Down here is kind of like our word bank, and we're going to be pulling up information from here to fill in our statements and reasons. Now, you don't need a two-column proof unless you're asked to prove something, but there always has to be given information, and from the theorem, I hope you remember that the given information, or the hypothesis, was suppose that M is the midpoint of AB, so M is the midpoint. Now, the first part of the two-column proof is also the given information, so I can pull M as the midpoint right up there as well. Now, the first thing I can conclude, knowing that M is the midpoint, is that AM is equal to MB right here. Now, I know that only because of what I wrote previously. If M is the midpoint, well, then using the definition of the midpoint, I know that this section, is equal to this one. Now, part 3 makes sense. This is kind of separate. They say that AM plus MB equals the entire segment, AB. one part plus the second part equals the whole segment. That's the segment addition postulate. That's adding two parts of a segment to equal the whole. Now this is where things start to get a little tricky, and I'll give you this hint first. We're going to be using the substitution property, and we're going to be using it starting with this equation. We're going to be substituting something in. Now, I know that AM is equal to MB from this line. So I'm going to take this AM and plug it in for the MB that's here. Meaning, for this new equation, instead of MB, I now have AM plus AM. Now, from algebra, you know that AM plus AM is, oops, that's not the one I want, is 2AM. Right? That's just, well, combining like terms. Let me move these around. Combining like terms. Just have a few things left in our word bank here. Okay, so far we're so good, right? Okay, so AM plus AM is 2 AMs. Well, knowing from algebra, this is 2 times a variable equals something else. If I want to find out what AM equals, I'll have to divide by 2 on both sides. When you divide on both sides, that's the division property of equality. Anytime you do something on both sides, it's the division property of equality. Now this makes us happy because this is part of what we wanted to prove. But we also had to prove that MB was half of that. That's pretty easy. We're going to use the substitution property again, and here's how we'll do it. I will prove that MB is half of AB by just taking what I know from here, that AM and MB are the same, and now instead of AM, I will plug in MB. Now I have proven that if M is the midpoint of AB, then each of these segments is half of the whole segment.